Hello my dear learners, welcome back. So today in this video, we would be starting off with the new topic, permutations and combinations from 2nd PUC Basic Maths. Okay, so let me give you the definition of what permutation is. What is permutation? So today in this video, I would be discussing the basics of permutations. Okay, and in my later videos I would be discussing about combinations, but as of now the chapter's name, whatever we have started, is permutations and combinations. Okay, so on the screen what do you see? Okay, you see a key here, you see a code lock here, something, you see a sophisticated what do you say, arrangement here. So all of these look like a locker, correct? So now, how does a locker open? So locker opens with a code, okay, basically numbers. So this numbers you see on suitcases also. So on suitcases, what do you do? So there is a mechanism wherein you have to put in some digits as a code lock so that you only open your suitcase. So the same logic applies to a locker, which is a little more sophisticated, wherein you can store some gold for some security. Okay, so for example, if the locker has a code which says 2, 3, 4, 6. So this is the locker code which will open only if you put 2, 3, 4, 6. Now, for example, if I put the value 6, 3, 4, 2, will my locker open? No. Why will my locker not open? Because it is not in an arranged format, right? So after 2, so this is the locker code. This is the locker code. So if the locker code is 2346, if I substitute or put some other number, how will my locker open? Correct? No. So which means when I start putting that code word, that is 2346, so after 2 you're substituting the number 3. After 3 you're putting the number 4, and finally after 4 you're putting the number 6, correct, onto the locker. So what happens, there is a systematic arrangement of number one after the other, so as that locker opens. Okay, so in other terms, what is permutation? Permutation is nothing but arrangement of numbers in an orderly format, or arrangement of, okay, anything, whatever it is. Arrangement is very important. Arrangement, whenever you have, then it is permutation. Okay, blindly go for it, it is permutation. Okay, now whenever I come to permutations, there is something called as counting, correct? So when you come to count, okay, or when you come to find a number or some value, or how do you start calculating questions with related to permutations, there is something called as a factorial notation. So for example, if I write n, this notation is there, no, this exclamatory symbol, this is used for factorial. Okay, so this factorial notation, okay, AL. So this factorial notation, for example, if I tell, find the value of 3 factorial. So 3 factorial can be written as 3 into 2 into 1 factorial. The factorial values you people have done in lower classes. Okay, so just we all know that 1 factorial is 1. So 3 into 2 is equal to 6. So similarly, if I write 5 factorial, so we go in decreasing order, correct? So 5 into 4 into 3 into 2 into 1 factorial, which is equal to 120. Okay, so here what is happening? I am multiplying numbers. But why am I multiplying numbers? To find the total number of arrangements. Okay, so to find out the total number of arrangements, okay, factorial notation is used. Total number of arrangements, factorial notation is used. I hope everybody is clear with it. I hope everybody is clear with the basic definition of permutation. Now, moving on to uh, a little more depth in factorial notation. Now, factorial notation, we all know that it is for finding out total number of arrangements. But in general, if I have something called as n factorial, this is in general, right? It is the general representation. But if I have to utilize or use the same n factorial inside our problems, okay, so what variety of formula does it become? So see, with this particular example, we all know that factorial notation, we take values in decreasing order and that to multiply it, and the ending number will always have to be 1 factorial. Okay, so in general, how can I write the values? So you will start with your representation 1, n, decrease the value, n minus 1 into n minus 2 into n minus 3 into dot 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 into 3 into 2 into 1. So what is happening here? Product of n natural numbers. So this is an example that I've given. So here n is nothing but the biggest number that is given to us. So for example, I have given here. So when n is the biggest number, a number little smaller than that is 2. So that therefore this n minus 1 is what? If n is 3, n minus 1 is 2. Correct? If n is 3, n minus 2 is what? 1. So therefore, whatever I have written here makes sense. So I hope everybody understood. So please make a note of this factorial notation. This notation is really very important. And one more very important thing which I would like to tell you all is, please by heart, actually, please by heart the factorial notations from at least 1 factorial to 6 factorial. So if you want, I'll just give you a note of what are the factorial notations from 1 to 6. Please make a note of it, all my dear learners. 1 factorial we already know is equal to 1. 2 factorial is equal to 2. 3 factorial we just now found out which was equal to 6. 4 factorial is equal to 24. 5 factorial also we found out which was equal to 120, and 6 factorial is equal to 720. So if you want to cross verify whether I've written all the factorial notations correct, please substitute the values, write it in decreasing order, multiply them and get your final answer. Make sure that the last digit should be 1 factorial. Okay, so moving further, one more very important note in permutations. Now, what is 0 factorial? Always understand 0 factorial does not have any value or any meaning. Okay, so in that case, whichever does not have any meaning, we consider it as 1. Understood? And the second very important note is the formula or denotation for permutations. So I think you people have come across NPR. Okay, now what is this NPR? Okay, now NPR is nothing but different ways in which our places can be filled when n things are given to us. So which means totally you have n things, okay? Out of the total number of n things, I have to fill r number of things. So what do you mean by that? For example, there are 10 vacant places, okay, out of which I can accommodate 6 places. Or to give you more clarity, there are totally 10 men, 10 men, okay, and 20 vacant places. Okay, so 10 men will require only 10 spaces or 10 places. So therefore, out of the 20 vacant places, I will make use of only 10 vacant spaces. Understood? So totally there are 20 vacant spaces, but I require Only 10 vacant spaces because how many men are there? 10 men are there. So as and when I proceed with the chapter, no, I will keep on stressing what is important, what is required and stuff. So therefore don't panic. So initial part of the chapter, sometimes it will be difficult. Sometimes if you go on reading it again and again or going through the videos again and again, you will find it easy. But when I come to the formula part of it, okay, so this is n factorial divided by n minus r factorial. So here I have given you what is this n. N is nothing but, okay, so this entire LHS, whatever I have written, let me just put it across in terms of words, okay. Different ways in which, I'm writing it in a different colored pen. So this different ways in which, okay, our places can be filled, okay, with n given things. So totally n given things, how can r be filled? Okay, so as and when the chapter proceeds, I will just let you know. But please make a note of this note number A and note B. Two more notes are there. Please make a note of it. I'll just write it somewhere here. So note number C, please make a note of. Note number C, I have NPN. See, this is the this will be the down part. Okay, NPN is equal to n factorial, and the last note is NP1 is equal to n. So these are all helpful when we do statement problems or proving problems with LHS and RHS. Okay. And one more very important keywords that you people have to remember is whenever you have addition to be performed. Okay. Whenever you have to perform addition on a question, always look for keyword always look for a keyword called as or in the question. Okay, one more very important note. Okay, when you're performing addition, look for keyword or in the question. Okay, when you're performing multiplication, you look for keyword and. Okay, please make a note of it. Students go wrong here only. So whenever there is, you will multiply. Whenever there is or, you will add. So hope you people have understood. Now this much is enough to start with our exercise problems. And there are varieties of ways, okay? There are varieties in the sense there are too many types of permutations. So I don't want to explain each and every type now only in this video. So what I'll do is I'll start with the exercise problems, okay? As and when whichever concept is required, I will take that or write it as a note. You people also make it a habit. Whenever I tell note, note is going to be very important. Okay, so that note you will make a note of, and then we will proceed with that. Okay, that note can be any information, or it can be what do you say, any identity or any formula for that matter. Okay, or whatever concept required for that particular topic will become your note. Or yeah, whatever I tell you, please make a note of it so that this chapter goes on very smoothly. So I hope fundamentals of permutations you people have understood. Whatever is required also I have given as certain notes, and you people have taken it down. So if you have still not understood, please pause the video, replay from wherever is it required for you all. Please understand the concept and then only proceed, because we all know, my dear learners, concept is our strength. Meet you in the next video. Until then, stay tuned. Thank you all.